Hi, I'm Dr. Christine Embury. I'm a postdoctoral research fellow working on examining the utility of OPM MEG in children with epilepsy. So OPM MEG, or optically pumped magnetometer magnetoencephalography, is a way to look at how the brain behaves and interacts with itself and other parts of your body while you're resting or performing different tasks. It's a non-invasive functional neuroimaging tool that can measure the magnetic fields that arise from the electrical activity of the brain. From this signal, we're able to identify activity from populations of neurons, something on the order of tens of thousands of cells, but within just a couple of millimeters of space. It's related to other neurophysiological measurement techniques like electroencephalography or EEG, and cryogenic or traditional MEG, but it can fill in several of these gaps in these techniques, optimizing the scanning environment for children and particularly those with epilepsy. The precision of this technique is highly important for those with epilepsy, where identifying where abnormal activity arises from can mean identification of a surgical target or a more targeted intervention. The precision to be able to measure this activity every millisecond or faster within just a few millimeters of space means more precise interventions can be employed for children with epilepsy, especially surgical patients. In addition, since there is some literature suggesting that MEG can be even more sensitive to spike detection, we are also trying to see if we could even use our OPM MEG system to initially diagnose epilepsy by comparing spike detection between our scan and other scans like the clinical EEG or the EEG that we can take concurrently. This can enable those unable to handle the sensory experience of EEG application, all the glue and stickies, to get a critical scan and diagnosis using equipment that's similar to a bike helmet, no glue or tape involved. So our main aims are to compare our scan to clinical standards like clinical EEG or a concurrent EEG if we can, and determine whether we're able to detect and map the activity with same or greater accuracy. We hope that this technique will be adopted through the clinical pathway, which could vastly improve the diagnostic pathway and procedure planning for pre-surgical candidates. When you arrive at the center, we show you into the room where the scan takes place, so just in here, and let you try on the helmet and generally get used to the area. You can always bring a parent in with you, and a member of staff will always be in the room to help out. The OPM MEG sensors themselves are about the size of a Lego brick. There are 64 of them we can see in 128 different places, which is really cool. And they're all set into these kinds of helmets, kind of like a bike helmet, that are sized for different ages and head shapes. And they just all slot in just like that. So we may ask you to measure your head ahead of time so we can get the helmet prepared. We may also ask you to wear EEG electrodes underneath this helmet so we can get the best possible comparison between the two techniques. We'll ask your parent to fill out a set of basic questionnaires about your medical history and behavior. Once we go over the consent process and we're prepped, and then we have you get ready in the room, we can put on your favorite movie or show while we set up. We'll take a fun 3D scan of your head and the helmet so we can find out where in your brain we're getting all the signals from relative to all the sensors that we have on your head. We can send you a small clip of this after your visit. Then we will start the scan, which will last up to an hour. We may ask you to perform some optional tasks like naming pictures on a screen, moving your finger kind of funny, or pressing a button on a button pad. You might have to listen to beeps or just watch some things on a screen. We may also ask you to rest with your eyes open or closed. We can also just turn on a show to watch. Any data while you're in the scanner is helpful for us. Once we're done in the scanner, we'll take off the helmet and the EEG sensors if you did this as well. And that's it. We'll contact you some weeks after for a post-scan interview to find out how we can improve, the visit, the environment, and that's it. So the study is still ongoing, but we're already seeing some of the data come together, and we're able to see and map spikes in the brain in all kinds of different presentations of epilepsy in children. Some of our preliminary findings will be shown at national and international conferences this year, and look out for some initial papers soon. We're still recruiting and adopting more sites, so please get in contact if you're interested in being a participating site or are interested in larger collaborations in general. Otherwise, feel free to look around our website for different information or see my contact information here. You can reach out to us by our email, opmmeg@youngepilepsy.org.uk. Thanks.